Hey there, everybody. I just wanted to kind of walk you through the lab and practice exercise. So, like I mentioned in class, this one's slightly different than the other ones we've had because, here, I'm dragging it over here. You can see that this is both a lab and a practice exercise together. So it's basically asking you to complete a couple of different analyses and then to summarize your findings. And I know we've only walked through these analyses really quickly in class, so I want to go ahead and walk you through how to do them on SPSS, and that way you'll have a video. So perhaps for your own individual questions when you're going to be analyzing stuff on your own, you can look back at this and see how we did it. So let's go ahead and start here with question number 1 under one sample t-test. Asks you to complete a one sample t-test to see if the average number of hours practiced by Berkeley students in a statistics course differs significantly from the Berkeley student population average hours practiced of 15.50. So you'll see this is one that we've done before. So let's go ahead and run through how we would run a one sample t-test comparing our sample average hours practice to the Berkeley population value 15.50. So I'm going to minimize this. Here I am back at my data set. And let me go to, okay. So what you can see up here, here's my data set. Up here we've got all of our options. And as always, I go to Analyze. And then I go to Compare Means, fourth one down. And you can see I have some options, one sample t-test, independent sample t-test, which we'll use later. But let's go ahead, we're doing the one sample t-test. So click on that, and then this dialog box comes up. And what you need to do is choose your test variable. So find the variable you want to test and put it over there. So we want to test hours practiced. Let's see, where is that? There, hours practiced. And so we want to test our variables, our samples, number of hours practiced, against a known value, right? The Berkeley population average hours of practice. So we know that that value is 15.50. So that's all I want to do. Let me check options, nothing, sorry. So I think all you have to do now is press OK. And then you should get the following output. And so this output, again, it shows you, here's your variable, how many people you had in your sample, here's the mean, here's the standard deviation, the standard error, the mean. Here is our t-test. So it's negative 4.476, which we would round to 4.48. Here's our degrees of freedom. Here's our p-value, 0.000. So this is a significant finding, right? So that's how you'd run the analysis. But obviously, to answer the question, you want to summarize the findings from this test and use the write-up slide to help you provide the correct information. So what you could do, what I would honestly do is just go to the PowerPoint that we had in class. All right, so here's the lecture on t-tests. So you can scroll down to how to write up a t-test, one sample t-test. This is exactly how I would write it up. So, I mean, you don't have to reinvent the wheel. If you want, you can copy it and paste it onto this. But just so you know, the way that you would actually write this up is like it says on this slide. You need to specify what the samples are. You be sure what it is that they do or do not differ in, and then provide a little bit of statistics, right? So that's what I'm asking you to do here, is let me know. I'm going to go ahead and read this so you can, oh, pink, it's more fun. So you can see this is how I would summarize the findings from this test. So we saw, by doing SPSS and completing that analysis, you have done this part. Here is where you'll say what you found. The average number of hours practiced each week in our class was significantly lower then the average amount of hours practiced for the Berkeley student population. And then I would write up t-value, how many degrees of freedom you had for your test, the actual t-value, and whether or not you're finding the significance associated with that t was less than 0.05. All right, so that's one. Let's go ahead and look at the next one. Complete an independent samples t-test on the average hours of practice for males and females enrolled in a statistics course at Berkeley. If you haven't noticed already, I'm asking you to do stuff we've already done in class. That way you can kind of look back at the slides if you need to remember how to do this and remember what these tests are and what they mean. But let's go ahead and look at SPSS and see how to do that. So again, here we are in our SPSS data set. If I want to run this analysis, I go up to Analyze. I go to Compare Means. Oops, sorry. And then Independent Samples t-test, because I'm comparing two groups of people within the sample. So I have my whole sample, and then I have boys and girls in the sample, males and females in the sample. I'm comparing those two groups. So I click on Independent Samples t-test, and the test variable I want to know about is hours practice, because I want to know if boys and girls or if males and females differ in number of hours they practice. Where I put in gender is in this grouping variable. So I'm telling it I want to make two groups out of my sample, and I want them to be divided by whether they indicated their gender was male or female. So I put that gender variable in here, but then I also have to define the group. So I basically have to remind SPSS how we know what groups are what. And so when you click on that, you get this box comes up. And so group 1, let's see, I have boys coded as 1 because boys are number 1, but I have girls coded as 2 because girls are second to none. That's how I remember that. I know, it's lame, but it works. So that's it. Once I've specified that, I say continue. I'm going to check options really quick. Nope, I don't need any extra options, so then I could just click OK. And again, here is our output. And here's what you will see. Oops, sorry, it's really big. There. And so again, you always have this statistics, this group statistics, or this like descriptive statistics table that tells you the variable you're looking at, the two groups you've made, the number of participants in each group, the mean and the mean for each group. So we can see males have a higher mean number of hours practiced than females. Standard deviation for each of those groups, and the standard error of the mean. So again, when we come down here to look at the result of our independent samples test, you can see first we have our Levine's test. And this test is testing whether or not this variability, so whether the variability around the mean for men and the variability around the mean for women is basically equal. And we can see they are slightly different. But this test is going to test this Levine's test for equality of variances. This is testing whether or not they're so different that we can't assume that they are the same or that they're close enough. And so if this is significant, if this value is less than 0.05, then you have to assume that the variances are not equal. This test is significant, saying they are not equal, and you have to drop down and read from this row. So this row just kind of changes the data for you so that you can interpret it and not violate the assumption that these are equal. But ours is not significant, so this test is saying that they are not significantly different, and so we can proceed as if they are the same, and we can read this top row. So here's our t-value, here's our degrees of freedom, here's our significance value. And so this is where you'd want to see if this value is less than 0.05. And so here's our SPSS output. Again, if I want to write these results up, I want to make sure that I am doing it like our write-up was telling us to do. So honestly, I would go to the slide that shows us writing this up right here. And you can see we've got the same exact kind of information. If you have a significant level or a p-value, a significance level less than 0.05, then it's significant. And to write it up, you want to compare the mean of one sample to the mean of another sample so that you can see which one is larger than the other. So you want to compare the mean of males to the mean of females so that you can interpret this when you write it up. Make sure you specify what the samples are, what the groups are, right? Males and females, and be sure to mention the variable you're looking at, what it is they do or don't differ in hours of practice. And this is how I would write this one up. So let me go ahead and bring up your worksheet here. So there's a couple ways you could write this one up. Because our significance level was 0.08, you could argue that there's something called a trend for males to practice more than females. However, honestly, if you're going to use the hard and fast 0.05 rule, which is totally fine, a lot of people, I mean, that's recommended, then you could say that there was no significant difference between the amount of hours of practice reported by males, and I'd usually put the mean in there. Equals, what was it? Let me see. There. So, sorry, let me move this around a little bit. Here we go. M equals 11.65. And the standard deviation for everybody, so they know what my descriptive statistics looked like. So there was no significant difference between the amount of hours practice reported by males and females. And then I'm going to go ahead and put in the female statistics, which is a mean of 7.29 and a standard deviation of 3.64 when we round up. And then I could put my T information, 1.82. I could either say P equals 0.08. I could also say P was greater than 0.05, showing them that it wasn't significant. Or I could just write NS, not significant. But basically that's how I would report it. And again, I would always put these means in when you're reporting it. So I know I didn't do that in the slide, but here it is. There's a trend for males to practice more than females. Here's the female mean and standard deviation. So we'll put that in here. There. So either one of these would be totally fine. If you want to say that there's a trend because the p-value is less than 0.10, it's not a significant difference. You can't reject your null hypothesis, but you could say there's a trend. But you can also say there's no difference. Oh, and here's your last question on independent samples t-test. This is supposed to be correlations. There. So on question number 5, according to Levine's test of equal variances, did you assume that the variances of the groups of males and females were equal or unequal? So I'm basically just asking you, was Levine's test for equality of variances, was it significant? And it was not. So I would just say that I assumed the variances of each group were roughly equal because the Levine's test was not significant. That's good enough. All right, last one, correlations. So complete a correlation among the two variables, confidence in instrument and confidence in performance. So again, let's go back here. Correlation between confidence in instrument and confidence in performance. So again, analyze. This time, instead of going to comparing means, because we're not comparing means, we are looking at relationships among variables. So you can just go to correlate and do this one called bivariate, meaning two variables. So two variable correlation, bivariate correlation. So we're clicking on that, and again, you get this dialog box, right? And in here, you just want to say what variables you want to look for a relationship between. So I want to go down to, right down here, instrument confidence. So how confident you are in your instrument, and performance confidence, how confident you are in your performance. This is letting you know you're using a Pearson correlation coefficient. You pretty much always use that. This is showing you that it's already saying you're going to use a two-tailed test of significance, which we always do. And this little check mark means that it's going to put those little stars, the asterisks, by the significant correlations. Let me make sure there's nothing else we want to do here. Nope. Okay, so all you have to do is say okay. Maybe. Oh, sorry. Okay. And here is our information. So here is our correlation. And you can see here we have, this table is telling us here is the two variables, instrument confidence, performance confidence. And they actually go, so the two variables are organized from top to bottom. They're also organized from left to right. So again, if you want to read this, you need to read the intersection of your two variables. So instrument confidence and performance confidence. So here is my correlation coefficient, 0.712. So that'll tell you Pearson correlation, that's the coefficient. And here's significant level, 0.001, and that is also given to us by how many stars there are behind here. If there's 1 star, then it's significant at the 0.05 level. If there's 2 stars, it's significant at the 0.01 level. And the N is telling you how many people you had who reported both of these values for both of these variables. So it's how many observations this relationship is based on. And so again, here's our correlation coefficient of 0.712. It is significant. And so if I go back to this, in one short sentence, summarize the findings from this, that's supposed to say test, geez, Alicia, and use the write-up slide to help you provide the correct information. So again, sorry, I have a cold. Okay, so again, if I was going to write this up, I would want to say I could just look at the PowerPoint. So here's the correlations PowerPoint maybe. It's slowly opening. Well, again, you could look at that slide and it would tell you what to write up, but I would just say, I would want to say what variables I'm talking about, what the direction of the effect is, and a quick interpretation of what that means, and the basic level of statistics so people can understand what I'm trying to show them. So I would say confidence in instrument was positively correlated with confidence in performance. And then I would report my correlation, 0.71. Just rounded the second decimal place, and I would let everybody know that the p-value is less than 0.05. And then I just quickly interpret it, indicating that, again, this is a positive correlation, so that means high scores go with high scores, low scores go with low scores. So indicating that the more confident students feel in their instrument, the more confident they feel about performing. And sometimes I'll put the opposite as well, so or that the less confident students feel in their instrument, the less confident they feel about their performance. All right. So this is how you would do those tests. So again, and that's the kind of answer I'm looking for in this. So I don't want you to have to calculate this stuff by hand. It was really just to have you do it by SPSS and then interpret it. So again, really quickly, to do the t-test, you go to Analyze, Compare Means, one sample t-test for the first one. For the second one, you'd go to Analyze, Compare Means, and Independent Samples t-test. And for the third analysis, you'd go to Analyze, Correlate, Bivariate Correlations. All right, email me if you have any questions, and I hope that is helpful.